Hello everyone, welcome back to Lemon Code 21. In this session, we will learn Docker Compose. This is the material that we will discuss in learning the Docker Compose. In the previous discussions, we have learned many features of Dockerfile. Introduction to Docker Compose. Docker Compose is a tool used to define and run multiple Docker containers simultaneously. By using Docker Compose, we can use a YAML file to configure these Docker containers. With a single command, we can create and run all the Docker containers specified in the configuration file. This eliminates the need to manually type the docker create command when creating Docker containers. Having multiple isolated environments on a single Docker host server, or referred to as projects, allows us to create numerous types of environments for Docker Compose. By default, the project name will be based on the configuration file's folder name. Docker Compose can detect which containers need to be created or updated when changes are made to the configuration file. It avoids recreating containers unnecessarily, only creating the containers that have been modified. Creating a development environment. When developing applications, we often require different tools for each project. Docker Compose can be used to set up and manage these environments efficiently. Automated testing. When performing automated testing, there are often multiple components that need to be manually set up and coordinated. Docker Compose can help automate this process, making it easier to set up the required environment for testing. Deployment. Docker Compose is also applicable for deployment scenarios. It allows us to deploy our application without the need for manual startup on the server. By using Docker Compose, we can efficiently manage the deployment process of our application. Installing Docker Compose. In the past, Docker Compose was a separate application from Docker. We needed to use the Docker Compose command to utilize Docker Compose functionalities. However, in the latest Docker versions, Docker Compose is now integrated within Docker itself. To use Docker Compose, we can simply use the command Docker Compose version. This integration simplifies the process and makes it more convenient to manage multi-container applications using Docker Compose directly from the Docker command line interface. Configuration files. Docker Compose stores its configuration in a YAML file yaml.org. YAML files are similar to JSON, but are more straightforward and easier to read. Typically, the configuration file is saved with the name Docker Compose, Yaml. As mentioned earlier, the project name by default will be based on the folder's name where the Docker Compose, YAML file is located. At the time this video was created, the Docker Compose configuration was still using version 3. You can find the latest version on this page, docs.docker.com. Please note that this refers to the version of the configuration file, not the version of the Docker Compose application itself. YAML. YAML is a file format commonly used for storing configuration data. It is similar to JSON, but does not use curly braces. In YAML, data is represented using attributes and values. It provides a more human-readable and concise way to express data structures compared to JSON. Well, here is an example of two files, YAML and JSON. YAML, it is a lightweight, human-readable data representation language. It is primarily designed to make the format easy to read while including complex features. Since YAML is a superset of JSON, it can parse JSON with a YAML parser. The extensions in YAML are .yaml or .im. YAML specifications allow user-defined data types as well as explicit data typing. More recommended in making Docker Compose using YAML file for readability. Create container. Previously, to create containers, we use the docker create command. However, now we can create containers using only the configuration file in Docker Compose. In the Yaml file, we can add a section called services to define the containers. Within each service, we can specify the container name and image for the Docker container we want to create. The correct command to create the containers defined in the Docker Compose configuration file is docker compose create. This command will create the containers specified in the Docker Compose YAML file. It is important to note that the Docker Compose create command is not a standalone command. It should be used along with other Docker Compose commands, typically as part of the container lifecycle management process. Start container. After creating containers, they will not automatically start running. We need to start them manually, using either the Docker Container Start command or Docker Compose. To use Docker Compose for starting the containers, we can use the following command: Docker Compose Start. Stop container. To stop containers, we can use the following command: Docker Compose Start. Using this command, we'll stop the containers defined in the Docker Compose configuration. It is important to note that stopping the containers will only halt them, but it will not remove the containers. Remove containers. If we no longer need the containers specified in the configuration file, we can remove them. We can manually remove containers using the Docker Container arm command, or we can use dockercompose.to remove containers. Using Docker Compose, we can use the following command: Docker Compose down. By using this command, all containers, networks, and volumes associated with the containers specified in the Docker Compose configuration will be automatically removed. Okay, now let's practice the steps to create a container using Docker Compose. First, we will create a Docker Compose YAML file with version 3.8 and configuration for the Nginx application service. We name the container Nginx example. Add the image attribute with the last image tag from Nginx. To execute Docker Compose commands in the terminal, you need to make sure you are in the same directory as your Docker Compose YAML file. This is because Docker Compose looks for the configuration file in the current working directory by default. Next, we create a Docker Compose. Let's check with container else. Okay, there is an error because I use Windows. It should use findstr or select string instead of greet. Now we turn on Docker Compose. Let's check Docker Compose is running with the Docker Compose C command. Now we turn off the container. We check Docker Compose is stopped. Service. In the Docker Compose configuration, containers are defined within a configuration section called Services. We can add one or more services in the configuration file. All right, now let's practice the steps to create services in Docker Compose. we'll use version 3.8. First, we'll create two services, Nginx example and mongodb example. The Nginx example service will use the latest Nginx image, and its container will be named Nginx example. The mongodb example service will use the latest Mongo image, and its container will be named mongodb example. Let's start by navigating to the service folder. We'll follow the usual steps. Docker Compose create and Docker Compose. Start to bring up the containers. After that, we'll use Docker Compose ps to check the status. Great, both containers are now up and running. So, the way to create multiple containers within services in Docker Compose is straightforward. Comment. One of the advantages of using YAML over JSON is that in YAML, we can add comments by prefixing the lines with the hash character. In JSON, we cannot add comments as part of the data structure. Comments in YAML are ignored by Docker Compose, meaning they are treated as non-essential information and do not affect the configuration or behavior of the containers defined in the Docker Compose file. Let's create a Docker Compose file first. For its contents, we just copy the previous one. Okay, so here we can make comments using hashtag symbols. That's the advantage of using YAML files over JSON. Port. When creating a container, we can expose ports from inside the container to the outside world using port forwarding. This allows external systems to access services running within the container. In the Docker Compose configuration file, we can achieve port forwarding by using the ports attribute. The ports attribute contains an array of port objects. Short syntax. When defining port mappings in Docker Compose, we can use two methods. The first method is the short syntax, which consists of a string in the format host port, Continer Port. For example, 8080 means that we will use port 8080 on the host machine to forward traffic to port 80 inside the container. Long syntax. For the long syntax, we can define port mappings using an object that contains the following attributes. Target, the port number inside the container that we want to expose. Published, the port number on the host machine that will be used for forwarding. Protocol, the protocol used for the port, TKEP or UDT. Mode, this attribute specifies how the port is published. For a single host configuration, we can use the value host. Sure. Let's create ports in Docker Compose. In this Docker Compose configuration, we will have two services with different port notations, one using the long syntax and the other using the short syntax. First, let's copy the Nginx example service from the previous Docker Compose file. Now, we'll add the port configuration using the long syntax, including the TKEP protocol, publishing port 8080, and targeting port 80. Next, let's copy the other service with the short syntax. We will change the port notation to 808180. Before creating the Docker Compose file, let's navigate to the port folder and create the containers. Then, run the Docker Compose start command. After that, we can check the status using Docker Compose ps, and you'll see that both services are running on different ports. To confirm, open your browser and you should see the expected results. Environment variable. When creating the container, we also add environment variables for use inside the container. When using the Docker Compose configuration file, we can add an environment variable using the environment attribute. Certainly. Let's set up an environment for Mongod using Docker Compose. In this scenario, we'll create a Docker Compose configuration with version 3.8. We will define a service named mongodbenv. Using the latest Mongob image. The container will be named mongodbexample and will expose the default Mongod port 27017. Additionally, we'll provide environment variables for username, password, and database with the value admin. Then, let's proceed to create the Docker Compose configuration and run the Docker Compose commands. Once completed, we'll perform a check using Docker Compose ps to ensure everything is running as expected. Afterward, we'll open Mongod using Mongod Compass and establish a connection using the username and password we've set. This way, we can confirm that the setup is functioning correctly. Bind mount. To perform a bind mount, we can also configure it in the Docker Compose file. We can use the volumes attribute under the services section. The volumes attribute allows us to add one or more bind mounts if desired. Each bind mount is specified in the former host path, container path. This means that the directory or file at host path on the host machine will be mounted into container path inside the container. Short syntax. For bind mounts, we can use both short syntax and long syntax in Docker Compose. For the short syntax, we can use the value source, target mode, where source is the location on the host and target is the location inside the container. Mode is bind mount mode, row for read-only, row for read-write, default. Source can use relative paths starting with point or absolute path. Long syntax. To use the long syntax for bind mounts in Docker Compose, we can create a nested object in the volumes attribute with the following attributes. Type, the mount type, which can be either volume or bind. For bind mounts, we use bind. Volumes will be covered in the next material. Source, the source path on the host or the name of the volume. Target, the target path inside the container where the source will be mounted. Read-only, a flag to set if the bind mount should be read-only. The default value is false. Let's now create a bind mount for MongoDB using Docker Compose. In this Docker Compose configuration, we'll use version 3.8. we'll have two services with different notations, one using the long syntax and the other using the short syntax. To begin, let's copy the existing MongoDB Docker Compose configuration. First, rename the service to MongoDB-bind1 and add the volume configuration using the short syntax. After that, create and run the Docker Compose setup. You'll notice that the data has been successfully created and stored in the specified folder. Moving on to the long syntax, we can copy the configuration from the short syntax. Rename the service to Mongo. Before that, we change the name of the service and the name of the container. If we have turned off the Docker Compose that we ran earlier, then we add the volume attribute by writing long syntax. We add several attributes on the volume such as type with value bind, source with value data, monog2, target with value data, deb, and finally read only with value false. Again, create the Docker Compose configuration and run it. Since the port is already in use, let's change it to 27018 for the second service. Now, you'll see that the bind mount folder has been created as expected. That's how you utilize bind mounts in Docker Compose. This approach provides flexibility for managing data between containers and host systems. Volume. Correct. Docker Compose is not only used for creating containers, but can also be used to create volumes. We can define volumes in the Docker Compose configuration using the volumes attribute. To use volumes in Docker Compose, we can define them in a manner similar to bind mounts, with the following considerations. Short syntax. In the short syntax, instead of specifying ASOURCE, we can use the name of the volume directly. Long syntax. To use the long syntax for bind mounts in Docker Compose, we can create a nested object in the volumes attribute with the following attributes. Type. The mount type, which can be either volume or bind. For bind mounts, we use bind. Volumes will be covered in the next material. Source. The source path on the host or the name of the volume. Target. The target path inside the container where the source will be mounted. Read only. A flag to set if the bind mount should be read only. The default value is false. Remove volumes. When we use the Docker Compose down command, only the container and network are removed. The volume will not be deleted. This is so that we don't accidentally delete the volume. If you want to delete a volume, we can do it manually with the command docker volume arm volume name. Let's create volumes for MongoD in Docker Compose. The process is quite similar to what we've done before. We'll start by copying the previous Docker Compose configuration and then adding the volume attribute to the services. To begin, duplicate the existing Docker Compose file. Next, add the volumes attribute to each service and provide a name for the volume you want to use. Let's create a data volume first. For the short syntax, the changes are minimal. For the long syntax, we'll modify the type to become volume. We change the type and source according to the data volume. Then we create Docker Compose and run Docker Compose. If we have checked first with Docker Compose OP, it's important to note that when you create a Docker Compose configuration with volumes, the volumes are automatically created. However, if you stop or remove the Docker Compose setup, the volumes will not be automatically deleted. Network. Besides creating containers and volumes, we can also use Docker Compose to create networks automatically. Default network. When we run a Docker Compose file, by default, all the containers defined in the file will be connected to a network with the name project name default. The network name is based on the project name specified in the Docker Compose configuration. This automatic network creation in Docker Compose eliminates the need to create networks manually. You can inspect the running containers using Docker Compose and check the network section to see how they are connected. Using Docker Compose for network management simplifies the setup of interconnected containers and allows them to communicate with each other easily within the specified network. Create network. Correct. If we want to create networks manually in Docker Compose, we can use the networks attribute. This allows us to define one or more networks with specific configurations. To create a network manually in Docker Compose, we need to specify the following properties. Name, the name of the network. Driver, the network driver to be used, such as bridge, host, or known. Let's first create a network folder. We'll start by creating its Docker Compose configuration. You can copy the Docker Compose configuration from the previous setup. In this new setup, we'll focus on creating a network using the bridge driver. Copy the Docker Compose configuration from the previous setup. Create a new section for defining networks using the networks key. Inside the network section, create a network named network example using the bridge driver. We add the network attribute in the service. Now create the Docker Compose containers as usual by running. If you encounter an error, it might be due to inconsistency in the network name. Ensure that you have consistently used the same network name, network example, in both your services and network definitions. After successfully starting the containers, you can inspect the containers to verify the network configuration. In the inspection output, you should see information about the networks the container is connected to. Make sure that the network example network is listed and properly configured. By following these steps, you can create a network using the bridge driver in Docker Compose. The network ensures that your containers can communicate with each other using the defined network configuration. Depends on. When creating a Docker Compose file containing multiple containers, sometimes we need to ensure that certain containers start before others. In other words, we want to define the order of container execution. By default, Docker Compose starts all containers simultaneously without any specific order. However, we can control the order of container execution using the depends on attribute. The depends on attribute allows us to specify dependencies between containers. We can mention in a container that it should only start after another container has started. We can specify one or more other containers in the depends on attribute. Let's start by setting up a dependent folder. We'll create its Docker Compose configuration. You can copy the Docker Compose configuration from the previous setup. In this scenario, we will create two services that are interrelated, one for mongob and the other for mongob express. Copy the Docker Compose configuration from the previous setup. For the first service, mongob view, you can keep it as it is since you have already created it. Now let's create the mongob express service. Use the latest image available. Add a new container with the name mongob express, depends on, and set the environment variables as needed. Adjust theme config mongob server environment variable to match the name of your mongob service container. This environment variable is used by mongob express to connect to the mongob server. I tried to adjust some of the environments in the Docker Compose file first. Before proceeding, stop any existing services using the Docker Compose down command. Create and start the Docker Compose containers. Check the status of the Docker Compose services. At this point, you might notice that one of the services is still down, likely mongob express. This could be due to the second service needing some time to connect to the first service. If you inspect the logs, you might see connection errors between the two services. This is because the second service, mongob express, is trying to connect to the first service, mongob, before it's fully ready. Let's run Docker Compose again. If we look at the Mongo Express browser, it's already running and we can use it. By following these steps, you can create two dependent services using Docker Compose. The depends on attribute ensures that the second service starts after the first service and gives it some time to establish a connection. This setup allows you to create interconnected services within your Docker environment. Restart. By default, when a container stops, Docker does not automatically restart it. We need to manually restart the container if we want it to run again. However, we can configure a container to always restart in case of failures or other conditions using the restart attribute. The restart attribute allows us to define different restart policies for the container. The available values for the restart attribute are: no, this is the default behavior, where the container will not be automatically restarted. Always, the container will always be restarted if it stops. but it won't be restarted if it is manually stopped and Docker is restarted for the first time. On failure, the container will be automatically restarted if it exits with a non-zero exit status, indicating an error. Unless stopped, the container will always be restarted, except when it is manually stopped. Sure, let's create a reset scenario using Docker Compose. We will modify the existing Docker Compose file to incorporate the restart attribute for the MongoDB Express service. This approach is intended to handle connection failures by restarting the MongoDB Express service until it successfully establishes a stable connection. Add the restart attribute to the MongoDB Express service configuration and set its value to always. This tells Docker to automatically restart the container if it stops or fails, regardless of the exit status. Now, let's create Docker Compose and start. Check the status of the running containers. To observe the logs of the MongoDB Express service, you will notice that when the MongoDB Express service encounters connection failures, it will automatically restart until it establishes a stable connection with the MongoDB server. The restart always attribute ensures that the container restarts whenever it stops or fails. Resource limit. You are correct. We can use the Docker Compose configuration file to set resource limits for CPU and memory for each container we create. To achieve this, we can use the deploy attribute and then specify the resources attribute within it. Within the resources attribute, we can define two properties. Reservations. This property sets the guaranteed amount of resources that can be used by the container. The system ensures that this amount is always available for the container. Limits. This property sets the maximum limit for the resources allocated to the container. However, keep in mind that these limits can be contended with other containers if the overall system resources are constrained. Sure, let's create a folder and a Docker Compose file for their source and limit topic. We can start by copying the Docker Compose file from the previous container topic. After copying, we will add the necessary ports. Now, under the service configuration, add the deploy section and specify the resources attributes. We'll add the resources and limits attributes by utilizing the deploy section and resources reservation. We'll set the CPU limit to 0.5 and memory limit to 100 MB, while also setting the CPU reservation to 0.25 and memory reservation to 50 MB. Now, let's navigate to their source limit folder and create the Docker Compose file. Then, start the Docker Compose process. Check the status of Docker Compose afterward. Upon observation, you'll notice that the memory limit for ThingInk's example container is correctly set to 100 MB. This helps ensure controlled resource usage for your containerized application. Dockerfile. You are absolutely right. In addition to creating containers from existing Docker images, Docker Compose can also be used to build containers from Docker files that we create. This feature simplifies the process, as we don't need to create the Docker image manually before running containers. Let's create a Dockerfile folder and build a Dockerfile for a simple application. In this example, we will use Python FastAPI for the simple application. Create a folder named App for your FastAPI application. Navigate to their source limit folder in the terminal. Set up a virtual environment, then vapp folder. Install the required dependencies using pip. Install FastAPI and Yaml. Create a simple endpoint in your FastAPI app that returns a welcome home FastAPI message. Run your FastAPI app. We check in the browser. Okay, that's good. It worked fast. Make sure to use pip freeze to generate a list of dependencies. Create a new file named Dockerfile in the Dockerfile folder. Use the official Python image as the base image. Set the working directory within the container. Copy the requirements file and install dependencies. Copy the FastAPI app files into the container. Command to run the FastAPI app using Yaml. Sure, let's go through the process of creating the Docker Compose file for your FastAPI. We use Docker Compose version 3.8. Let's define name service for FastAPI app. Add context, as specify the context, location of your Dockerfile. Add Dockerfile attribute, as specify the name of your Dockerfile. And add image as name of the image that will be created. Then we create Docker Compose and run Docker Compose. If we have checked first with Docker Comps OPs. Okay, all running. In essence, creating a Docker Compose configuration from a self-made Docker file empowers us to streamline the deployment of our applications, resulting in efficient, consistent, and easily managed containerized environments. Health check. We've discussed about container health check in the Dockerfile material. By default, containers created, either manually or using Docker Compose, will always use the health check created in the Dockerfile. However, if we want to change the health check, we can do that too. We can change the Docker Compose configuration file to the health check attribute in services. The health check in Docker Compose has several attributes that define its behavior, similar to when we define a health check in the Dockerfile. Test. The test attribute specifies the command or script used to perform the health check. It determines whether the container is healthy or not. The test command can be specified in different forms, such as command, k, cell, or none. Interval. The interval attribute sets the time interval between consecutive health checks. It determines how often Docker will run the health check command to monitor the container's health. Timeout. The timeout attribute specifies the maximum time allowed for the health check to complete. If the health check takes longer than this value, it will be considered as a failed health check. Retries. The retries attribute defines the number of times Docker will retry the health check if it fails before considering the container as unhealthy. Start period. The start period attribute specifies the time duration before Docker starts performing health checks. Sure, let's delve into the topic of health checks. To begin, we'll create a new folder and copy all the files from the previous setup. We'll make a slight modification to the Python file, updating it to return a Docker Compose health check response. Next, we'll incorporate health checks into the Docker Compose configuration. We'll add a health check to the service by performing a curl test to the health endpoint of our API. We'll set parameters such as an interval of 5 seconds, a timeout of 5 seconds, 3 retries, and a start period of 5 seconds. Additionally, we'll introduce a new endpoint named Health in our application. Upon hitting this endpoint 5 times, the application will respond with an HTTP status code 500, simulating an unhealthy state. Once the setup is complete, we'll build the Docker Compose configuration, create the container, and launch it. Now, let's check the status repeatedly by running the command docker ps as a result. We'll observe that the API initiates calls in a repeating pattern of 5, which triggers the defined health check parameters. Consequently, the status becomes unhealthy, aligning with the pre-configured settings. In summary, implementing health checks enhances the monitoring and stability of our containerized applications. Extend service. When building applications using Docker, sometimes we want to run the application to multiple servers. Whether it's on a local laptop, on a development server, or a production server. Sometimes there are times when things are different, like configurations, for example. In this case, like it or not, we have to create a lot of Docker Compose configuration files, for example for local, development, and production. Docker Compose has a feature called service extension, where we can merge multiple configuration files together. This feature allows us to create a common configuration file and then override or extend it with specific configurations for different environments. For example, when running Docker Compose, we can use the F option followed by the name of the YAML file to specify a different configuration file other than the default Docker Compose. Sure, let's create an extend service folder and replicate the contents of the existing Docker file. Docker Compose em Add app files. We'll make some modifications to the Dockerfile. Specifically, we'll add environment variables app port with a value of 8080 and mode with a value of local. Additionally, we'll change the keyed entry to be a string instead of an array. In the Fast API application, we'll incorporate the app port and mode variables from the Dockerfile we created earlier. In the Docker Compose, we'll add a new environment variable mode with a value of local. Before proceeding, let's first stop the existing Docker Compose if it's running. Next, we'll build, create, and start the containers. You'll notice that the mode in the Fast API app now has a value of local. Now let's explore how to configure different modes such as dev and production for our Docker Compose setups. For dev mode, we'll create a copy of the Docker Compose YAML file and name it dev.yam. In this copy, we'll remove any unused attributes, leaving only the environment with mode set to dev. Similarly, for the prod mode, we can create another copy named prod.yam and change the mode to prod. Before proceeding, let's make sure to stop the Docker Compose again. To build and run the different modes, we'll use the specific extended files when creating and starting the Docker Compose. You'll notice that the mode changes from local to dev when using the dev.yaml file. If we look at the results, the mode that was local changed to dev. And similarly, it changes to prod when using the prod.yaml file. This way, we can easily configure different modes for our Docker Compose setups. As a result, the previous dev mode has also changed to prod. Certainly, learning Kubernetes would be a valuable step to complement the Docker deployment process. Kubernetes is an open-source platform designed to manage, automate, and scale containerized applications. It's a powerful tool for orchestrating, designing, and running complex and large-scale applications with ease and efficiency.